Hi, I'm Matt Blair, VP Operations at Qube Technologies. I'm here today at our test facility to demonstrate the process of assembling and installing our emissions monitoring device. In order to accomplish this, you'll need a few tools, including an impact driver, a long shank 5/16" hex driver, and a Phillips driver. You also need a securely mounted pole. For this, Qube recommends using 2" EMT conduit, which is designed to fit into the central bracket on the back of the device. The installation kit includes several components. The core device, which comes with the main central bracket and solar panel mounting brackets pre-attached. A solar panel, in this case a 45-watt variant. An anemometer for measuring wind speed and direction. And our canister-style inlet vent filter. We'll start the assembly process by installing the anemometer. To accomplish this, we first need to assemble it. You'll note that the anemometer comes in two components, the support arm and the main body of the instrument. In order to assemble it, first remove the 3mm Allen key set screw from the support arm, and then gently pull the cable through while pushing the end of the support arm into the body of the anemometer. When you're doing this, take care not to pinch the cable during the process. The support arm should slide straight into the body of the anemometer. There should be no significant resistance, and don't twist the anemometer once it's onto the support arm, as this could damage the cable. We then simply reinsert the set screw, which again is a 3mm. There's a 3mm Allen key included in the anemometer box, and I just like to use this tool. It makes things a little easier. We'll then use the provided 4 1032 machine screws to attach the anemometer to the top of the main central support bracket. And note the direction that I'm mounting the anemometer, so it should be facing such that it's hanging out over the core device. We'll then tighten the 4 machine screws. Now that we've attached the anemometer, we'll install the device onto the solar panel. You'll note that the solar panel support brackets and the back of the panel contain a series of 6 pre-drilled holes. And we're going to use 6 self-tapping metal screws in order to complete this process. With the solar panel attached, we can now take the device and position it on our 2" EMT conduit mounting post. And you'll notice there are 2 cables, one for the solar panel and one for the anemometer. They're color-coded, and they can be clicked into these 2 barrel connector bulkheads in the bottom of the device. I like to thread the anemometer cable here through the back of the solar panel bracket, just to kind of tuck it in out of the way. These connectors have a little red dot in the front of them, and you'll see a corresponding dot in their bulkheads. And when positioned correctly, they can be pushed up into the device, and you'll hear a quick click telling you that they've been connected properly. The final step in the physical assembly process is to install the canister-style inlet vent filter, which threads into the bottom of the sensor assembly. Note that this is a replaceable part. It can also be cleaned on a periodic basis. In most locations, a maintenance interval of approximately 6 months should be sufficient to maintain airflow through the sensor assembly seen here in the device. So we also want to ensure that the solar panel mounting brackets are tightly secured to the main central bracket. And note that on the bottom bracket there are actually a series of 3 holes in which this screw can be threaded into to tilt the solar panel. So, up here in Canada or anywhere where you're likely to experience significant snowfall in the winter, we recommend mounting the solar panel in this orientation where it's almost vertical. In places that don't experience snowfall, you'll improve efficiency somewhat by tilting it out to 30 degrees or so. So the next step in the process will be to turn the device on, and for that we'll need our Phillips driver bit, and we'll remove the 4 Phillips head screws attaching the case cover. Now, one thing to point out before interacting with any part of the inside of the device, make sure you touch a ground point to prevent damage from electrostatic discharge. I'll touch this screw in the top corner. With the cover removed, you'll notice in the top left-hand corner there's a small plastic tab labeled Power On Off. We're going to remove that tab, breaking a circuit which activates the device. I then take the tab and insert it back on one of the 2 jumper pins for storage. And this will start the process of the device activating. So you'll notice here we have a status indicator light. It will first pulse white for a couple of seconds, indicating that the device is in its boot up cycle. We should then see it begin to blink green, kind of rapid fashion, and that tells us that the cellular modem is searching for a cellular network. After that process is complete, you'll see it blink rapidly blue and then settle on a slow sort of breathing pulse blue pattern, and that's what tells us that the device is now in its operational state. So with that complete, we can replace the cover. When you're doing this, have a quick look at the gasket that surrounds the cover here and make sure that it's not twisted. So with the device physically assembled and powered on, the next step will be to scan the QR code here on the side of the case with your mobile phone's camera app, and that will enter you into Qube's mobile installation wizard. What this is doing is identifying the unique serial number of this device and using the GPS on your phone in order to register the coordinates of the installation location within our platform. So you'll be able to reference our installation guide, which will help walk you through the process of using the mobile installation wizard. Essentially, we walk through about 3 steps, and then when we arrive at the final step, we'll click Finish, and the device will now be fully registered. One point to mention during this process, your phone is going to ask you to allow the use of location services by your browser, and during this point of the process, please click Yes. This will greatly enhance the accuracy of the GPS coordinates saved by the device, which will improve the performance of the system. Now with the device assembled and turned on, there's one final step in the process, and that's alignment. We've left this step until the end. It's actually vitally important to ensure the accuracy of the localization and quantification results. You'll notice on the anemometer there's an indicator here marked S, which is standing for south. The anemometer is necessarily, according to the design of the device, facing the same direction as the solar panel. So our objective here is to ensure that the solar panel faces as closely as possible to due geographic south. And that, of course, is in the northern hemisphere. One caveat: if you're in the southern hemisphere, we'll keep the same geometry with the anemometer hanging out over the main body of the device, but we'll point the solar panel north. And our team will apply an 180-degree offset to the wind direction data within our firmware. So there are a number of ways to do this. We do find that in an industrial environment, such as the environment in which our devices are often deployed, compasses can suffer from problems with interference. So one method is, if you have surveying gear available, to mark a point and flag it some distance away in either cardinal east or west, which can be sighted down the solar panel. I'm using a device known as a dual antenna GNSS heading module, and this device uses two GPS antennas in order to determine the heading of the device, so it's not susceptible to interference and the magnetic fields that your compass is reliant on. This is something, if you're having trouble with alignment, please reach out to the Qube team. We'd be happy to help you, but I just want to emphasize the importance. But once you do have the device in a south alignment that you're happy with, we'll just take, again, 4 5/16 head 3/4 inch self-tapping metal screws and drive them through the 3 pre-drilled holes in the central support bracket. This, of course, securely device against rotation. And that concludes our training session. Thanks for your time, and if you have any questions, concerns throughout the process, please feel free to reach out to our support department.